motivation behind this session is to make you guys aware of what are the most commonly used AWS services that are used in data engineering applications. This will basically help you in getting started with AWS. I will just touch upon the services just to make you guys acquainted with the AWS services, because it would be very difficult to go deep in all the services in this session, but we can go deep into the services in future sessions. So without any delay, let's get started. So let's suppose the data from production applications are stored in Amazon RDS and Amazon DynamoDB. RDS and DynamoDB are two very popular cloud-based database services which are offered by AWS. Amazon RDS stands for Relational Database Service. It is a managed SQL database service. As you all know that relational databases are an important component in any application, but sometimes they can become very difficult to manage or operate with high availability whenever you try to scale your application. So you also have to take care of caching, performance tuning, backups, scaling, and security as well. So the data administration is a very resource intensive task. So Amazon RDS comes to the rescue as it simplifies the database management service by automating all the administrative tasks. And we as developers just have to work on the optimization of our code and also running our queries. And it supports a wide variety of engines to store and organize data like Postgres, SQL Server, MySQL, or any other SQL engine. And then we have DynamoDB. It is a fully managed NoSQL database service, and same goes for DynamoDB database as well. You don't have to worry about the administration task since it is also a managed service. It is a good fit for systems that require high speed in data reading and data writing. It can also scale to more than 10 trillion requests in a day. For example, on Amazon Prime Day, Amazon used this service to handle large amount of requests that they receive on that Prime Day sale. So the first step would be to ingest the source data which we have in Amazon DynamoDB and Amazon RDS. So there are two types of data ingestion pipelines that we can build. One is batch ingestion and another one is streaming ingestion. Batch ingestion comes into picture when you want to bring large amount of data at once or at a particular schedule. So the first data source that we would want to ingest is RDS database. And use case for this would be, let's suppose you might want to do a bulk ingestion of all the historical data at once or at particular schedule. So which service would you use for this batch ingestion? It actually depends. If the data that you have to be ingested is small and you think it won't take much time, you can go with AWS Lambda. And so what is AWS Lambda? So it is just a computing service that runs the code in response to some events. Events might be like some object has uploaded into S3, or there is some updates in DynamoDB, or any other kind of event. It automatically manages the computing resources which would be required by your code. So you don't have to worry about administration. You just have to worry about the code that you might have that you might want to run whenever some event happens. But let's suppose if your data has millions or billions of rows that you might need, then you might need more computing power and the data would take more time to process. Then for this use case, you might want to go with AWS Glue. So AWS Glue leverages Spark, which processes the data in a distributed fashion. So it can process your data in parallel for faster processing, and thus it can also handle bigger data sets. For smaller data sets, you should go with AWS Lambda. There's another service that we can use to ingest our data, and that is Amazon EMR. Amazon EMR, with this service, you can use open source big data frameworks such as Spark, Hive, HBase, Pig, Presto, Hadoop, and also you can choose whichever version you want to use. But unlike AWS Glue, you would have to manage your EMR cluster, and you should know how cluster computing works. So now we have another data pipeline in which the data is updated in near real time in DynamoDB database. So we would want to ingest this data as soon as it gets updated in the database. So for this, there are 3 AWS services that can help us achieve this in real time. So we can go with Kinesis data firehose. If the data is in a DynamoDB stream, what we can do is we can invoke a Lambda function, which will send a batch of newly added items to Amazon Kinesis firehose. It will automatically scale to match the throughput of your data, and it does not require any ongoing administration. And the benefit is that you only pay for the data that you transmit through the data firehose service. But let's suppose if you want to perform real-time analytics on your data, which is in DynamoDB, then we can use Kinesis data streams and Kinesis data analytics. The benefit of this is that they provide inbuilt functions for filtering, aggregating, and transforming your data. So in short, where we have three Kinesis services for real-time streaming, we can use Kinesis data streams, which basically provides low latency streaming ingestion at scale. And then we have Kinesis data analytics. It can perform real-time analytics on streams using SQL. And then we have Kinesis data firehose. It basically loads data streams from various sources to data lakes or data warehouses. So till now, we have successfully figured out what services we can use to ingest our data from source databases. But now the question comes, what service can we use to actually store this data? This is where the concept of data lake emerges. We would use raw zone in AWS S3 to store all our files that we have ingested from our data sources. And it is a good practice to store the data in S3 as raw as possible, because the data is not yet ready for consumption. And it is also not yet ready for doing any analytics. So the good practice is to ingest all the data from a data source, since it is cheap to store in S3. And the idea behind ingesting all the data in S3 in raw format is, let's suppose a use case might develop later in future, which might need the raw data, which you don't foresee at the moment. So it's always a good practice to store the data from the sources as it is in the raw format in data lake. And after that, you can do the processing. So now we have data in S3 raw zone, and we would like to optimize this data, which is stored in S3 for querying purpose or for cleaning purpose, or cleaning up of some data columns, or maybe deduplicating the data that we have received into S3 from our data sources. So what we are trying to do is we are trying to make the data ready for analytics. So we can leverage AWS Lambda, AWS Glue, and Amazon EMR. So when we are done with the transformations and all the deduplicating and cleaning up of the data columns, we can store the data back to the data lake in the process zone in the S3 bucket. Right. So now that we have got our data in various zones in our data lake, so there might be many different zones as well. Apart from raw zone, process zone, there can be many other zones. So now we need a way to know where all of this data is and what are the schemas of the data. To achieve this, we have another service called Glue Data Catalog, which is actually within the AWS Glue service, and it will help you track where your datasets are in data lake and also maintains a schema of the datasets. It's actually AWS Glue crawler that extracts this information and make them available in AWS Glue catalog. And we can also run these crawlers periodically to make sure our catalog is up to date. And so let's suppose a new column has been added to dataset, then this Glue crawler will update that information in the Glue catalog. And now let's suppose if you want to build a data warehouse to analyze terabytes or petabytes of data, and you might have very long running queries with multiple complex joins. So for this, we would use AWS Redshift. It can scale up automatically depending upon how much compute we need and how large the datasets are. And Redshift is a OLAP database, which is designed to process large datasets. So then apart from this, we also have some data analytics services in AWS that you should have an idea of. So sometimes you might want to run some ad hoc queries on your data. And to do this, we can use AWS Athena. It integrates well with AWS Glue Catalog. So you can run SQL queries over the data, which is stored in AWS Data Lake directly. And you also pay for the data that you scan in the data lake. But you just have to take care of one thing. Just make sure your data lake is optimized before you start querying your data using AWS Athena. just to make sure, so that it will help you that you don't scan unnecessary data. And optimizing the data lake can help you save some money as well if your data sets are quite large, right? So then we have another AWS service that we have for analytics is AWS QuickSight. This is responsible for building analytical dashboards. We can make various graphs and charts to help make sense of our data for our end users. It integrates well with AWS Glue Catalog and AWS Athena as well. So this can basically help you in building dashboards right over the data in data lake. But we can also connect QuickSight to AWS Redshift or any other database wherever your data is present. So apart from this, we also have services that integrates all of these services. So if you want to implement some event-based data integration for your workflows, we have AWS Event Bridge, and this is the service to go for. If you can basically you can use this service to trigger an event by setting up some rule. For example, we can set up a rule for when a file is uploaded into S3 bucket, and then you want to send a notification to another service to trigger a different job to process it further. We also have Amazon SQS and Amazon SNS. SQS stands for Simple Queue Service. As the name suggests, it is a queuing service. Using SQS, you can send, store, or receive messages. And SNS stands for Simple Notification Service. It works on the publish subscribe model or pub-sub model using SNS topics. The publisher can send messages to large number of subscribers, and those subscribers can be your SQS, it can be your Lambda function, or it can be any other service. Now, let's suppose you want to orchestrate the jobs. Most of the times there are multiple glue jobs that needs to be triggered in a specific order for the job to complete, right? So for this, we can use AWS Glue workflows inside the AWS Glue service to orchestrate the ETL operations. So we can also use AWS step functions. You can go with glue workflows if you want to change multiple glue jobs or glue crawlers, usually for batch processing, and you can schedule these workflows in the AWS Glue service itself. But if there's a lot of complexity and the services that you want to orchestrate are beyond AWS Glue jobs, then you can go with AWS step functions. And when this pipeline runs, let's suppose there is some error in your pipeline and you just want to monitor the logs and analyze the logs which are generated by these data pipelines, we have another service called AWS CloudWatch, and it can help you achieve that. It can help you visualize the logs, it can help you visualize the metrics, and you can also take automated actions based on those metrics. So that's it for the session. Thank you.